For our project, we were assigned linear regression, so hopefully this presentation will help you review everything that you already know about it and help you relearn anything that you've forgotten by now. So what is linear regression? Well, a linear regression is a statistical method used to model and predict the relationship between two quantitative variables. Here are some variables of regression and some important definitions that you should know before you move forward with this presentation. In order to better understand linear regression, it's important that we understand how scatter plots are graphed and how they work. So for scatter plots, there are two variables involved in them, an x and a y. The x variable is the explanatory variable, which helps explain or predict changes in the y variable, which is the response variable. This measures the outcome of the study. When we're describing scatter plots, it's important to always mention these three descriptors, which are the direction, the form, and the strength of the scatter plot. Here are a few more variables and definitions that come in handy when you're learning about linear regression. Some of these variables and definitions include residuals, correlations, standard deviation, coefficient of determination, and the least squares regression line. Here are some notes about linear regression. So extrapolation, or the use of linear regression lines outside of the range of the data that is specified, should be avoided at all costs. This is one of the most common AP exam mistakes that people make. The R value doesn't change when we change the units of x or y, and the correlation R value itself doesn't have a unit of measurement. The correlation, mean, and the standard deviation are all not resistant to significant outliers. So now I'm going to help explain how you read the computer output that you usually are given in any exam or test. So the constant is where the y-intercept will be located, and the row directly below that is where the slope will be located. The SE coefficient, or the standard error coefficient, is the estimated spread or standard error of the sampling distribution of the variable of whichever row you're looking at. The S value is the standard deviation of the residuals, and the R squared value is the coefficient of determination, or just the R squared value. So here's how to solve for the y hat equals a plus bx equation using your TI-84. So here in list 1 I have all of the x data points, and in list 2 I have all the y data points. So what you want to do is go to stat here, calc, go down, see this is the first option here, but this one gives you ax plus b, we don't want that. Go down a few more, get to a plus ba, that's the right one. So press enter, and then you're going to put in list 1, separate the next one with the comma, list 2, and then just hit enter, and you'll have your whole output here for the y equals a plus bx equation. Here are a few helpful sentences that help you interpret variables on AP Stats FRQs. So there's a certain language that they'd like you to use, and this kind of helps narrow it down and simplify it. When you're describing the R, the correlation coefficient, you want to say there's a strong, moderate, weak, positive, negative linear relationship between and then the two variables. For the R squared variable, you would say this percent of the variation in the response variable can be explained by the linear relationship with whatever the explanatory variable is. For interpreting the slope, you would say for every 1 unit increase in the explanatory variable, our model predicts an average increase/decrease of whatever the number is in the response variable. For interpreting the y-intercept a, you would say at a, and then whatever the explanatory variable is, of 0 units, our model predicts, and then whatever the number is in the response variable. Another part of interpreting the variables is interpreting the residual plots. There are two kinds, the curved and the no pattern plots. For each different pattern, you would want to write down what's on the presentation here to best fit the AP exam's criteria. We listed some common FRQ problems that they ask in the AP exams. The 2010 FRQ number 6 and the 1999 number 1 are both perfect examples of these types of problems. They'll often ask you to construct a least squared regression line using a computer output, interpret a slope of a computer output, interpret the standard deviation in the context of a certain situation, or they'll ask you to interpret statistical tests or confidence intervals of slopes in the context of a situation. Finally, we listed here some common mistakes that people make in the AP exam. Oftentimes, people will imply causation instead of correlation between two variables. Also, students may sometimes define variables differently than expected, and these different definitions need to be noted in the conclusion. Finally, it's very important to remember that when interpreting the results of these problems, that the y-hat is actually the predicted response variable using the regression line. It's not the actual observed response variable.